Hello students, welcome to our channel H Mathematics. I hope you are all well. Matrix Part 2. Types of matrix. First, types of matrix. Definition of rectangular matrix. A matrix in which number of rows and columns are not equal is called a rectangular matrix. A matrix in which number of rows and columns are not equal is called a rectangular matrix. For example, a matrix 2 5 1 3 4 1 is a rectangular matrix of order 2 by 3. More example, a matrix 2 5 3 4 1 6. Here number of rows 1 2 3 and columns 1 and 2, they are not equal, so it's also a rectangular matrix of order 3 by 2. 3 by 2. Second type of matrix. Definition of square matrix. A matrix in which the number of rows is equal to the number of columns is called square matrix. A matrix in which the number of rows is equal to the number of columns is called square matrix. For example, a matrix 2 1 5 3 2 4 3 3 6 is a square matrix of order 3 by 3. Example, a matrix 1 2 4 5 B matrix A1 A2 A3 A4 B matrix 1 2 5 6 8 10 11 7 5 9 7 8 4 8 5 6. A matrix 1 2 4 5 is also a square matrix because number of rows and columns are equal. Here number of rows 2 and columns 2, they equal. And also matrix B 1 2 5 6 8 10 11 7 5 9 7 8 4 8 5 6. Here number of rows 1 2 3 4 4 and columns 1 2 3 4. Number of columns and rows of a matrix B is equal. So it's a square matrix. Third type of matrix, definition of diagonal matrix. A square matrix whose all elements except those on the principal diagonal are 0 is called diagonal matrix. A square matrix whose all elements except those on the principal diagonal are 0 is called diagonal matrix. For example, a matrix 1 0 0 0 3 0 0 0 2 is a diagonal matrix of order 3 by 3. More example, let a matrix A 1 0 0 0 4 0 0 0 5. Matrix A is square matrix. Also, all elements except those on the principal diagonal are 0. So it's also example for a diagonal matrix. All elements except those on the principal diagonal 1 4 5 are 0. So it's a diagonal matrix of order 3 by 3. 3 by 3. Here 1 4 5 are diagonal elements. 1 4 5 are called diagonal elements, and this line is called principal diagonal. Fourth types of matrix, definition of scalar matrix. Definition of scalar matrix: a matrix whose all elements except those on the principal diagonal are 0 and all principal diagonal elements are equal is called scalar matrix. A square matrix whose all elements except those on the principal diagonal are 0 and all principal diagonal elements are equal is called scalar matrix. For example, a matrix 2 0 0 0 2 0 0 0 2 is a scalar matrix of order 3 by 3. More example, let a matrix 0 sorry 4 0 0 0 4 0 0 0 4. Here all elements except those on the principal diagonal are 0 and all elements of principal diagonal are equal. So matrix A also example for a scalar matrix. Fifth types of matrix, definition of identity or unit matrix. A square matrix whose diagonal elements are all unity and other elements are all 0 is called an identity or unit matrix. A square matrix whose principal diagonal elements are all unity and other elements are all 0 is called an unit matrix or identity matrix. For example, 1 0 0 0 1 0 0 0 1 is an identity matrix of order 3 by 3. More example, let a matrix 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Matrix A 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Here all elements here a square matrix whose principal diagonal elements are all unity and other elements are all 0. It's called identity matrix or unit matrix and it's denoted by I4 because it's matrix of order 4 by 4. Here all elements on principal diagonal are unity and other elements are all 0. 6 types of matrix. Definition of null or zero matrix. Definition of null or zero matrix. A matrix of any order, rectangular or square, whose all elements are zero, is called null or zero matrix. Is denoted by capital O. For example, 0 0 0 0 2 by 2 matrix. And 0 0 0 0 0 0 2 by 3 matrix. More example. 0 0 0 0 0 0 0 0 0. It's also example for a null matrix or zero matrix, because it's a square matrix whose all elements are zero, and it's denoted by capital O of order 3 cos 3. It may be square or rectangular matrix. Seventh types of matrix. Definition of row matrix. A matrix having only one row or any number of columns is called a row matrix. A matrix having only one row and any number of columns is called a row matrix. For example, A 1 2 3 is a row matrix of order 1 by 3, because here number of rows 1 and columns 1 2 3. So it's a row matrix of order 1 by 3. More example. Let a matrix A 4 5 6 7 here number of rows 1 and column 1 2 3 4. By the definition of row matrix, it's also a example for row matrix. Column matrix. 8 types of matrix. Definition of column matrix. A matrix having only one column and any number of rows is called column matrix. A matrix having only one column and any number of rows is called a column matrix. For example, A 1 2 3 is a column matrix of order 3 by 1, because here only one column and 3 numbers of row 1 2 3. So it's example for a column matrix. Also example for a column matrix. Let a matrix A 4 6 7 8 9. Here number of columns only 1 and rows 1 2 3 4 5. By the definition of column matrix, it's also example for a column matrix of order 5 by 1. Ninth types of matrix, definition of upper triangular and lower triangular matrix. 9 types of matrix, definition of upper triangular and lower triangular matrix. A square matrix is called an upper triangular matrix if all elements below the principal diagonal are all 0. A matrix is called an upper triangular matrix if all elements below the principal diagonal are 0. Here matrix A 2 3 3 0 5 4 0 0 8 is an upper triangular matrix because all elements below the principal diagonal, here it is principal diagonal, below the principal diagonal are 0 0 0 0, and a matrix is said to be lower triangular matrix if all the elements above the principal diagonal are 0, and a matrix is said to be a lower triangular matrix if all elements above principal diagonal are 0. For example, matrix B 2 0 0 4 5 0 3 3 8 is a lower triangular matrix because all elements above the principal diagonal are 0 0 0 0. 10 types of matrix, definition of submatrix. A matrix obtained by deleting some rows or column or both of a given matrix is called its submatrix. A matrix obtained by deleting some rows and columns or both of a given matrix is called submatrix. Its submatrix. A matrix obtained by deleting some rows or columns or both of a given matrix is called its submatrix. For example, 4 5 5 2 matrix of order 2 by 2 is a submatrix of a matrix of 3 by 3 4 5 6 3 3 6 5 2 1. More example, let a matrix A 5 6 2 1 2 by 2 matrix and a matrix B 4 5 6 3 3 6 5 2 1 3 by 3 3 by 3 matrix A 5 2 6 1 of order 2 by 3 is a submatrix of matrix B of order 3 by 3 because matrix A obtained by deleting first column and second row. Eleven types of matrix, trace of a matrix, definition of trace of a matrix. The sum of all elements on the principal diagonal of a square matrix is called trace of a matrix. It's denoted by tr dot a. The sum of all elements on the principal diagonal of a square matrix is called trace of a matrix. It's denoted by tr dot a. For example, matrix A 2 3 1 4 1 2 5 2 3 of order 3 by 3, then the trace of A 2 1 plus 3 is equals to 6 because sum of the principal diagonal, sum of all elements on the principal diagonal 2 1 and 3. So sum of these numbers 2 plus 1 plus 3 is equals to 6. So trace of A is equals to 6. 12th types of matrix, definition of equality of two matrix. Two matrix A and B are said to be equal if they are equal of the same order and each elements of A is equals to the corresponding elements of B. Two matrices A and B are said to be equal if and only if they are equal of the same order and each elements of A is equals to the corresponding elements of B. For example, matrix A 3 4 0 minus 1 and B 3 4 0 minus 1. Matrix A and B are said to be equal because they are equal of same order. Here order of matrix A 2 by 2 and order of matrix B 2 by 2, and each element of matrix A is equals to the corresponding elements of matrix B. Here 3 3 4 4 0 0 minus 1 1. So matrix A and B are equal. So matrix A and B is equal. More example. Matrix A 1 4 5 6 of order 2 by 2 and matrix B 1 4 5 6 of order 2 by 2. Matrix A and B equal because here order of matrix of A 2 by 2 and matrix B 2 by 2 and elements of A is equals to the corresponding elements of matrix B. So matrix A and B are equal and it's written as A equal to B. Thank you.